Today's lesson will deal with factoring techniques. So we're going to use these factoring techniques to allow us to solve polynomial equations. So we have solved linear equations, quadratic equations, and now the task ahead is to how do you solve a cubic or a quartic and so on. And one of the ways is going to be to factor it as completely as we can and set those factors equal to 0. So this first page here we've already discussed, and just to be a general review, but our first step in factoring is always the greatest common factor. So take out what's common to every term. You may not always be able to do this, but you should always check and see if that's possible. Step 2 is going to be to look for special products. Now, a couple of these we have discussed already. For example, difference of squares. And remembering that our squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225 are the first 15 perfect squares. So we need to just recognize when we have difference, so we need to have a subtraction sign. We only have two terms, and they're both perfect squares. So if that's the case, the formula is if you have a squared minus b squared, you would be able to factor it to be a minus b and a plus b. Difference of squares, different signs. A couple examples. 4x squared minus 9, this is definitely difference of squares. There's two terms, it's subtraction, and these are perfect squares. So to factor this, I want to find what do I square to get 4x squared, or what is the square root of 4x squared, which would be 2x and 2x. Square root of 9 would be 3 and 3. Difference of squares, different signs. Next example is definitely difference of squares. I'd have 5x and 5x. I'd have minus 7 and plus 7. Next one doesn't appear to be difference of squares, but our first step, and we should have checked these in these other ones also, is to take out what's common. And I can see that we could take a 3 out of both of these terms, and I'd be left with 9x squared minus 25y squared. And this is an example of difference of squares. I'm just going to bring the 3 down, and I'm going to factor what I have here by using this process. So 9x squared are going to be 3x and 3x. 25y squared would be 5y and 5y. Difference of squares, or difference signs. And that would be factored completely. So difference of squares, you have two terms separated by a subtraction sign, and they're both perfect squares. For a perfect square trinomial, this is going to be something that has 3 terms. It's going to begin and end with a perfect square. And if that's the case, we're going to factor it as a plus b squared or a minus b squared, depending on what that middle term is. So examples here, I look at this one, there's 3 terms. It begins and ends with a perfect square. So I'd have 2x and 3. This tells me both signs must be positive, so that's going to be positive, and I'm going to square this. This next one's a trinomial, begins and ends with a perfect square. So I'd have 5x, square root of 1 is 1. Again, both signs must be negative, so it'd be 5x minus 1 quantity squared. So those are a couple examples that we have already discussed as our first steps in factoring. Look for difference of squares or a perfect square trinomial. All right, now, something that's a little bit new since we're expanding this is we could have difference of cubes. So to do this, we have difference, we have a subtraction sign, and then we have two perfect cubes. Remember that, or this is going to be our list right here of perfect cubes. Those are the first 10. Because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. So you can see that how to factor this is we take the cube root of the first term and the cube root of the second term, and the minus sign stays. And then we are going to square this term to get the a squared. We're going to multiply these two together to get the ab, and we're going to square this term to get the b squared. So for example, 8x cubed minus 27. I recognize this as a perfect cube and this. So my first factor would be 2x, because 2 cubed is 8, and x cubed is x cubed, minus 3, because 3 cubed is 27. That's extremely important that you can get that first factor, because now, to get the rest of it, I square this, I multiply these together, and I square this. This sign will always be positive, and this middle sign will be the opposite of what this sign was. So if that's minus, this would be plus. And that is completely factored by difference of cubes. Another example here. I recognize that to be difference of cubes. This would be 5x, because 5 cubed is 125. 27 is 3 cubed, so it would be 3y. It's going to be minus. Just bring that down. And then I follow the process. I square this term, 25x squared. Multiply these together, 15xy. Notice I'm not putting the sign in yet. And then I square the last term. This is always positive, and this needs to be the opposite of the first sign. And I've got it. This next example doesn't appear to be difference of cubes, but I could take a greatest common factor. I can take a 3 out of each of these. I'd be left with 27x cubed minus 8, which now this is difference of cubes. Bring the 3 down, I'd have 3x minus 2, because 3 cubed is 27, 2 cubed is 8. And then I square the first term. I multiply the 2 together, and I square the last term. This is always positive, and the middle sign needs to be opposite of what I started with, which is a minus sign. And that is difference of cubes. Sum of cubes. So the only thing that's different here is I have sum, and therefore I will begin with a positive, and the second sign will be opposite of that. All right, so this next one, I have 2 terms. This is a perfect cube, and this, what cubed is 64? That's 4, so it'd be 4x plus 1. And then I'm going to square the first term. I'm going to multiply them together, and I'm going to square the last term. And I messed up here a little bit. This will always be positive. This middle sign should be minus, because it's opposite of this first sign. Next one, I can see these are both perfect cubes, so it's 3x plus 10y. And then I square the first term, I multiply, and I square the last term. This is always positive, and this should be minus. This last one here, now this one here, this is x to the 9th, which is a perfect cube because it's a multiple of 3. So I could think of that as 2x to the 3rd cubed. And 27y to the 6th would be 3 cubed is 27, and y squared cubed is y to the 6th. And then I would follow the same process. Square the first term. That'd be 4x to the 6th. Multiply those together, which would be 6x cubed y squared. And that needs to be minus. And square the last term, which would be 9y to the 4th. Now, for this case, I would just check this and make sure that when you multiply these together, that gives you your 8x to the 9th. And when you multiply your last terms together, that gives you your 27y to the 6th. All the other terms when you distribute will cancel out, and this one works. So hopefully this can help you